All right, section 1.6. The parent function is the original function. Some might call it the OG. So, in this particular situation, this right here would be your parent function. Now, an absolute value function has a vertex. That's a place where it changes directions. A point where the graph changes directions. And then the axis of symmetry would be the line which cuts it in half. Parent function is just your basic function, so maybe I should state that, I don't know. In this case, we're using the absolute value function. So remember, absolute value is the distance away from 0. So how far is -2 away from 0? That's 2 units. How far is -1 away from 0? That's 1 unit. How far is 0 away from 0? 0 units. And 1 is 1 unit away, and 2 is 2 units away. So if you graph these things, you're going to get, that just looks horrible. Let's try that again. So we see that we're getting this kind of shape. Well, what's G like? Well, G, it's got a negative y. Remember, that's on the outside of the function? And if it's got a negative y, hopefully you realize that that would be flipping it over the x-axis. So if I plug in -2, the absolute value of -2 is 2, but then there's this other negative on the outside. So even though the inside part is 2, that one on the outside makes the overall thing -2. And -1, and 0, and 1. Nope, -1, and -2. So we get this kind of picture. So just reflecting over the x-axis. Domain and range. For the original one, -infinity to infinity, and for the range, 0, infinity. For the blue one, still -infinity to infinity, but the range is different. from negative infinity all the way up to 0, including 0. Next. So remember, we're going to talk about the things, changes on the outside and the inside of the function. So this minus 4 is on the outside, so that's going to be follow our common sense. Hopefully you would say down 4. Oh. This thing's going to start like this and go. Domain still negative infinity to infinity. Range would be negative 4 to infinity. Next one, two things going on. One, we got the reflection, since that's a change on the y. Since it's on the outside, it's changing the y. So if you took your absolute value function and you flipped it over, we already know what that looks like from the previous slide. But then we've got this up 5. So we know it's going to start up there and open down. We got negative infinity to infinity for the domain, but the range is obviously negative infinity to positive 5. Oh, that's got to be a bracket on the left side or the right side. You can never get a bracket on infinity or negative infinity. Okay, the next one's on the inside, right? We know that changes on the inside are backwards of our common sense. So this would be right 3. And so we would expect it to look something like that. Negative infinity to infinity, with the range being 0 to infinity. Just because we moved it to the right doesn't mean that the range changed. And lastly, on the far right here, we've got, once again, changing the y values. If you're changing the y values, you're doing that reflection across the x-axis. So we know we're starting out with the upside down version. But inside here, we know that this says left 2. So domain stays the same. Range, negative infinity, all the way up to 0, including 0. I see a mistake. I hope you caught it before I did. That can't be. It has to be a bracket. Seriously. Can't let those things go. Mr. Stailey. It's ridiculous. Graph the following. Well, I hope that you know that that is right 2 and down 5. And right 2 down 5. Right 2 down 5 looks like that. Domain negative infinity to infinity. And range -5 to infinity. Okay, several things going on in the next one. We got a reflection. Remember that changing the y's. So I know that this thing's going to be upside down. It's going to open down. And we got a left 4. And we got an up 3. Oh. Yeah. If I switch to a different color. Left 4, up 3, and it's upside down. So we go from negative infinity up to 3 in bracket. They, as a reminder, this is the first thing that they show you is a reflection. Of course, we can see that that is on the outside. So that's changing the y, which we know that goes across the x-axis. Because we've drawn those pictures before where you're taking a dot and you're changing the y value and it's going across the x-axis. Okay? And then, of course, they're trying to show us, changes on the inside and changes on the outside for vertical shifting and horizontal shifting. And this particular letter that they have out there is on the outside. So we know that is stretching or shrinking. Which direction? Well, if it's on the outside, it's got to be changing the y value. So it's a vertical, which makes sense because that's what it says right above it. Given the parent function. Okay, so now we've got this parent function. Graph and describe the transformations. Okay, so first we got a vertical stretch. Okay, now the reason I say stretch is because it's bigger than 1. So that means every point gets moved up twice as far from the x-axis. Okay, so that's the first thing. Okay, then we've got left 3, down 1. Okay, so I'm going to take this orange graph, I'm going to pick it up and I'm going to go left 3 and down 1. So there's 1 point. 2 points. So the purple one is my final graph. On the next one over. Phew, what do we got going on here? So 2 things right here. It's a negative, right? So that's a reflection across the x-axis. So that just flips it upside down. But we also have a shrink, a vertical shrink by 1/2. So basically that's what I just drew. Now we've got right 2 and up 10. So right 2 and up 10. That's my vertex right there. So the blue one is my final graph. 4 things that went on right there. Write the equation that represents each absolute value graph pictured. Okay, so notice that the slopes of the lines are just 1, and it opens up. So it opens up, slopes equal 1. So we've got absolute value of x. It also moved right 1 and down 4. So right 1, down 4. This one slopes, it's going down. You know what, I should back up. Truthfully, the slopes are plus and minus 1. So if I'm being completely honest, I should have said plus and minus 1. And so when I get over here, guess what? Also plus and minus 1. But the key thing is it opens down. It opens down. It also went left 3 and up 2. So we need all that to be said here. So we're going to have a negative on the outside of the absolute value bars. We need to go left 3 and up 2. Now this last one has slopes of plus and minus 1/2, down 1 over 2. And we know the thing opens down. We know the whole graph got moved up 5 units and no left and right shift. So we'll have our negative 1/2. No left and right shift, so there's nothing on the inside with the x. but it did go up 5 units. See what our last graph is here. Jay rides in a boat from his home to his friend's home in a neighboring state. Rides in a boat from his home to his friend's home in a neighboring state. Well, guess we got a sailboat going on here. I don't know. Maybe he crossed a river. I don't know. This is the graph of the function. Shows the distance of the boat in miles from the state line at t hours. How far does Jay travel to visit his friend? In the picture, you can see that it's decreasing on the left side and increasing on the right side, past 1.5. Well, so looks like Jay traveled an hour and a half to get to his friend's house, but then he traveled an hour and a half home. So when it says, how far does Jay travel to visit his friend, I'm like, okay, just to get there to see him? Or do you mean to get there and get back? So that's a kind of a misleading, because I'm like, I would say 1.5 hours, but if you're saying with travel time to get back, then total of 3. Is that all they're asking me here? Assume the graph shows Jay's entire trip. Yeah? Okay. So I need a little bit more specific information. Would I say 1.5 or would I say 3? So I'm going to leave it at that. I would be more specific on the test.